Hi, I'm François Bouteille again, and I will start speaking about the content of a training for compressed air. The first point was what we called traditional course plan. So for compressed air, the traditional course plan will be, will be very often like that. Starting, they will tell you that there is 21% oxygen and the rest is nitrogen. This is the information, this is true. It may be useful for compressed air used in respiration, for breathing, but this is not something which is so frequently necessary to explain to people who operate a compressor station, you know. And I would say that this will be something which may be not needed, but sometimes people believe that they have to have such knowledge also, so why not? Then we may speak about compression as a function, you know, a thermodynamic function. Compression can be adiabatic. This means that while the air is compressed, you do not cool it, so it becomes very, very hot, you know. You may have isothermal compression and polytropic compression. So isothermal compression means that you cool the compressed air in a way that it keeps the same temperature as in the inlet, and polytropic will be something in between. So you may, after compression, discuss compressors. So compressors, air compressors have some very classical divisions, subdivisions. You may have volumetric compressors. These are, for example, the reciprocating compressors and the screw compressors. All these compressors will close a small part of space, you know, with a very tight mechanical way, and then reduce it, always by mechanical way, and then they will put this air in the pipework under pressure. You may have compressor which will be centrifugal. This is a different kind of compressor. Centrifugal compressors, centrifuge. In these compressors, there's no closing a mass of air in a space which you reduce. It's rather like a fan giving a speed to the air, and then putting this air, which has taken a very high speed, putting it in a place where it can slow down, and then you transform the kinetic energy of compressed air into energy, potential energy, pressure energy. So these kind of subdivisions are very interesting, you know. You may also have divisions based on the quality of air. Some compressors are oil-free, other compressors are produce air, lubricated air. So this is all things which are very interesting. But in my first presentation of what we believe is the need of some different people, I remind you, we had some people who make operations, you know. They operate. Very often what they need is something much more practical, you know, the way of repairing, maintaining a compressor, you know. The people who want to outsource they usually wish to limit the knowledge they have to the result of the compression. They have air with such a pressure, such a quality, and maybe such a cost, you know, such a energy consumption and investment cost. People who make conception may be interested in knowing very precisely these things, you know, really. So conceptors, people who make the design, designers. Oh yes, these people will like to know about the families of compressors, to choose the right family. Of course, they will not be interested in knowing exactly how to repair the compressor. These people are working in offices, you know, not in the compressor station. And finally, people who make auditors, well, probably they will need to know that. But most of the content of their report will not be about changing the compressors. You know, you cannot come in a factory, and if the people have bought a compressor which is not exactly what would be the best, you know, very often it's difficult to change an investment. You cannot buy a new compressor to save 5%. Using a compressor with a better efficiency, you know, this is difficult. So they will work, auditors, much more on how to use less compressed air. This is the essential point. You know, if you stop using compressed air, you don't need any compressors. You know, would be the ideal situation for auditors. So what would come after that? We may speak about the theory of humid air. Well, here I'm in atmospheric air in France, and we have some humidity, maybe 2 or 2.5% of humidity of the volume around me is water on gas form, you know, and so this humidity, this water, when you compress it, and if you compress it in a way which is close to isothermal compression, then you will get water, liquid water. And if you happen to be in winter in a country where the temperature might become inferior to 0 Celsius, then you can get ice in your compressed air, you know, and it will block the flow sometimes because there is no enough room for the air to go, you know. So the theory of humid air is something that you can study very. It's very interesting and necessary, you know. And you can speak about dryers, compressed air dryers, and filters. Filters, separators, all means which remove the water or the oil once you have been able to condense it, and so also drains. This is a very important technological part, and this is a scientific part which we can associate to it. After that, I would say that the traditional course plan, which is something really very rational, you know, and very interesting to follow if you have 3 or 4 days, is the description of the pipework or network. Essentially, you have two or three aspects, you know. You may have a pipework which is like this, you know. And you may have, so the air comes in and goes in your plant to several places, like antennas, you know. And you may have what we call loops, des boucles. You may decide to have here several final users on one boucle, one loop, one. So this is a construction way, a way of designing the pipe work, which is sometimes preferable, better, you know, because you reduce pressure drops. It's not always necessary. It makes also measurement more difficult. For example, here you see that you may measure here by putting a flow meter here. You may measure the consumption of this area, but then knowing the consumption of this area, you would need to subtract this flow from this flow, and subtracting flows makes uncertainty of measurements very, very high sometimes. So you see, pipework design is something very important. You may design also material, pipe material, stainless steel or some plastics or carbon steel. This is the kind of things that you see in pipework, you know. And then probably you will have options. The main options that you have at the end of that is energy consumption, energy consumption of compressors is something that will be of interest for many operators, you know, especially if they have the decision maker has decided to save energy or not to spend too much energy or to manage energy. So energy is one option. This will be option one in many cases. Then you may have maintenance. Option two might be maintenance. How do you maintain the compressors? Reliability, notions of reliability. And there might be also an option three. Option three would be, in some plants, like pharmaceutical plants, quality of compressed air, safety, the kind of things that we call, together with reliability, la sûreté de fonctionnement. I don't know how to translate that. The global safety of exploitation. So this what would be a traditional course plan, and we do so in France. We have such offer of training for people who want a rather theoretical and a bit universitary scholar way of showing things, of seeing things. This needs three days. Normally it's 3 days. Sometimes it's 4 days. We take in 4 days when you want to have practical preparation to maintenance, you know. So in my diagram, you see reliability goes rather with option 3, and maintenance might be completed by some mechanics training. You know, you open the compressor, and with mechanics you learn to change the screw, for example, or to change the engine, the electrical engine. So this is the end of the third part of my presentation, and we shall continue to show another kind of training, which we believe is based more directly on the analysis of needs. Thank you for your attention, and I hope that it will be a bit useful for you.